Hey guys, this is the 7-2 notes, but right now I want to just go over a couple homework problems that I know you guys had yesterday. So I want to focus on these three problems, 26, 27, and 28. So 26, I believe, was saying that you had $2,000 in the bank at 4%, and that you wanted to know how much money you were going to be earning in 3 years. So I'm just going to remind you that the equation we learned the other day was y is equal to a times b to the x, where a is the initial amount, okay? B is your either growth or decay factor. If you're earning 4%, in this case it's going to be a growth factor, okay? Also, we learned that B, if for growth, is equal to 1 plus whatever the rate is, okay? And then X represents the time. Okay, so let's write an equation for this and then solve and then figure out how much money you're going to have. So B in this case, let's first of all, A in this case is 2,000. So we're going to have Y is equal to $2,000, okay? Times, now here's my growth factor. It's going to be 1 plus 4%. So remember, we have to convert 4% to a decimal, which is 0.04. So it's going to be 1 plus 0.04, which comes out to be 1.04. Okay, if you put 1.4, then that means you're earning 40% on your money. As it is, there's no such thing as 4% right now, but let's just pretend. So 1.04, and then we want to know how much you're going to have in 3 years, so that's to the third power. If I go to my calculator, it comes out to be 2,000, I'm just plugging it in, times 1.04 up arrow to the third. I get that I would have after 3 years $2,249.73. Okay? If you got a ridiculously high amount, it's probably that you didn't convert the rate right. Okay, really quickly, I want to touch on this one. How long to get to 2,500? So here's the equation you would set up. 2,500, when is that going to be equal to 2,000 times 1.04 to the x. Now I just want to make a point here. See, when the x is your the variable is your exponent in this case, we don't know how to do that yet. We're going to learn to do that when we start learning logarithms, okay? So as of right now, we cannot do this one, okay? But we will learn. All right, number 27 is a population problem. Population is at 120,000. When it's growing at a rate of 1.2%, how much will it be at 15 years? So think about this. Y is equal to the original amount, which is 120,000, times the B in this case, because it's growth, it's 1 plus the rate. I'm going to convert this rate to 0.012. Everybody see that? So it's plus 0.012. So here's what my B is. It's 1.012, and that's to the 15th power. Okay, so you could plug that into your calculator. Let me do it right now. It's 12023 times 1.012 up arrow to the 15th power. I get 143. Now in this case, guys, these are whole people. You're not going to round, so you're going to make this 100. It looks like it's going to be 143,512 people. Okay, hopefully you guys got that. Hopefully I didn't screw it up. All right, just want to make it a point here that now when we're talking about exponential decay, when it's decreasing, now it's going to be 1,860,000, and this is what y is going to equal. And now check it out. This is decreasing, so it's decreasing by 1.5%. Now in this case, my b is going to be 1 minus 1.5%. So convert 1.5% to 0.015. So 1 minus 0.015. I'm going to do that on my calculator. 1 minus 0.015 comes out to be 0.985. So that's my B in this case. And think about how that would make sense. That means that after 1 year, you're only going to have 98.5% left if it's decreasing by that. So we're multiplying that. We're going to put that to the 12th power because we're talking about 12 years. So when I put that in my calculator, I get 1860, times 0.985 to the 12th power. it would be a population of 1,551,485 people. Okay? So again, in the case of growth, your B is greater than 1. In the case of decay, your B is somewhere between 0 and 1. Okay? All right. Or sorry, somewhere between 0 and 1. All right, I'm going to go now to the 7-2 notes, and I'm going to just do a little of that, and we should be okay. Okay, don't worry about the SAT problem. We're just going to skip that for time's sake. I want to talk about translating. Everybody remembers this graph, right? This is the absolute value graph. If I was to say y is equal to the absolute value of x plus 3 minus 1, I'm going to remind you that this represents a horizontal shift, 3 to the left, and this represents a vertical shift, 1 down. Okay, so I would take the whole graph and I would shift it all 3 left, 1, 2, 3, and 1 down. Okay, so this is my graph right here. Okay, just reminding you of the shifting because it's going to come into play because we're going to graph some exponential functions. What would you say is the parent function of an exponential function? Well, I think it's just y equals b to the x. That's your parent function. All right, what does the a, the number in front of the b, do to the graph? Well, let's see. If I had this function here, y is equal to, let's say, 2 to the x, okay? Let's do an xy chart for this, okay? Let me just see what the values are here. I've got -2. So if I had -2 and I plugged that in, well, now think of how this is going to graph. It's going to be, what is 2 to the -2 power? Well, that means, remember what negative exponents mean? Is we put 1 over 2 to the +2. So that's 1/4. What if I plug in -1? That's 2 to the -1 power. It's 1 over 2 to the first, which is just 1/2. If I put in 0, what's 2 to the 0? It's just 1. Anything to the 0 power is 1. What about if I plug in 1? I get 2 to the 1, which is just 2. If I plug in 2 to the second, I get 2 to the second. Oh, sorry, if I plug in 2, I get 2 to the second, which is 4. Okay? All right, I want you to, I'm scrolling on to the next page because I have all of those values right here. Oh, I did a third value. I did 2 to the third, which is 8. Okay, let's graph that. Okay, actually, let's not graph that. Let's just graph, actually, let's graph that. We're going to graph that right here. Yeah, we'll graph at least some of it, okay? If I first plug in -2, I get 1/4. Okay, when I plugged in -1, I got 1/2. When I plugged in 0, I got 1. When I plugged in 1, I got 2. When I plugged in 2, I got 4. And when I plugged in 3, I got 8. So we're way the heck up there. So 4, 5, 6, 7, 8, right up there. Okay? All right, this represents exponential growth, right? This graph will never get below 0. See that? It's going to be like that x-axis is something called an asymptote. So this is growth because look, my b is greater than 1. So it's growth. Okay. So the question was, what does the a, in other words, if I put something in front of the a, what is that going to do to my graph? Well, let's take a look. Okay. So let's do this. We'll plot this again. -2, 1/4, 1, 0, 1, and 1, 2, and 2, 4. Okay, we got our graph, and then 3, 8, 4, 5, 6, 7, 8. There's my graph. Okay, I didn't really probably need to do that again. Let's see what happens with if I change this now, and my a is now 1/2 in front. Okay, let's see what happens. Well, that is going to be 1/2 of 2 to the -2, which is, I came out to be 0.25. So what's 1/2 of 1/4? It's 1/8. So when I plug in -2, I get 1/8, so even lower, okay? When I plug in, this is now going to be 1/2 times, I came up with 0.5. What's 1/2 of 1/2? What's 1/2 times 1/2? It's 1/4. This is 1/8, okay? So So now we're at 1/4, okay? Now I plug in 1/2 of 2 to the 0, so it's 1/2 of 1, which is 1/2. So at 0, I'm at 1/2. 1/2 of, well, 1/2 of 2 to the first, so it's 1/2 of 2, which is 1. Sorry I'm going so fast, but you guys could slow down and look at it whenever you want. So 1, 2, and 1, and then 1/2 of 2 to the second, so that's 1/2 of 4, which is 2. So 2, 2 is my point. And then 1/2 of 2 to the third, so 1/2 of 8. What's 1/2 of 8? It's 4. So when I plug in 3, I get 4. So look what it does to my graph. It kind of flattens it, okay? All right, I want you guys to try this one. It's going to be, now my A is negative 1/2, okay? You guys give it a shot, and I'll get back to you, okay? Pause your video. Okay, let's do that one. So if I plug in negative 1/2, and I'm plugging that in, and I'm multiplying that by 1/4, what would I get? I would get negative 1/2 times times 1/4. So I would get negative 1/8. Okay, so when I plug in negative 2, I get negative 1/8. When I plug in negative 1, I would get negative 1/2 times 0.5, which comes out to be negative 1/4. Oh, check it out. Look what happens here, guys. All of my points are being reflected, right? Look at, if I do this all out, and now when I plug in, I'll do the last one. Negative 1/2 times 8 is negative 4. So I'll plug that in. This is going to be negative 2. This is going to be negative 4. So just pointing it out, that this is the effect it's going to have. All right, we're going to do one more together, and then we're going to be done with this video. Okay. I want to show you this. This is important. This is the parent function. This is the A. That's going to be a shrink, right? If it's a negative number, it's a reflection. And then check it out. That's going to represent a horizontal shift. Okay? This is going to represent a vertical shift. All right, so think about it. It's just like kind of how we do it. If this is a minus, so if I had like -2, we'd shift 2 to the right. If I had +2, we would go 2 to the left. If this K was +1, we'd go 1 up. If it was -1, we'd go 1 down. So here, let's just do it. All right, here you go. So here's my graph, my thing. It's y equals 8 times 1/2 to the x, okay? So here's the thing. Is this growth or decay? This is absolutely positively decay because my b is less than 1. So this is decay. All right, let's just plug numbers in. So if I plug in 8 times 1/2 to the -1, well, this is a tricky one. This is the big tricky one. 1/2 to the -1, that means it's 1 over 1/2. And if you keep, change, and flip, you're going to get 2. So this is equal to 2. When I plug in -1, I get 2. Okay, there's my point right there. Hold on. Let's do this. I forgot. I want to erase this. I don't like this line here, so let's erase that too. We're erasing that line because I need to go way high. Watch, you'll see. Okay, so this is negative. So this is, when I plug in -1, I get 2. It's that point. All right, let's plug in 0. What's 1/2 to the 0? Well, it's just 1. So what's 8 times 1? It's 8. So when I plug in 0, I get 2, 3, 4, 5, 6, 7, 8. Okay, that's 0, 8. Let's plug in this. What's 1/2 to the first? It's just 1/2. What's 8 times 1/2? Please, you guys, don't forget order of operations. You're not going to multiply the 8 times. You got to do the exponent first and then multiply by 8. So 1/2 to the first is 8. Is 1/2 times 8 is 4. So when I plug in 1, I get 4. Oh no, hold on, this isn't right. Oh, I'm sorry. I screwed this up. This first one is going to be 16. Because, look, check it out. That's what I get. 1/2 is 2. When I multiply 8 times 2, I get 16. So sorry. Watch, check it out. I get 9, 10, 11, 12, 13, 14, 15, 16 is way the heck up here when I plug in -1. All right, so let's erase this. Sorry about that. And then when I plug in, oh shoot, look what happened. It erased that. Let's get that all set. Let's get like I'm just whiting it out, guys. You can do that with your white ink, right? Okay, next one. If I plug in 2, it's 1/2 to the second. Well, what's 1/2 to the second? It's 1/2 times 1/2, which is 1/4. So what's 8 times 1/4? It is 2. So when I plug in 2, I get, hold on, when I plug in 1, I get 4. We forgot that part. And when I plug in 2, I get 2. Okay, so my graph now is going to look something like this, and that's exponential decay. It's never going to get to 0, so here, it's going to look something like that. Let's do the red. Are you ready? This is going to go 2 left. This is going to go 3 up. The plus with the exponent, that's my horizontal shift. Okay, and then the one that's just kind of afterwards is the vertical shift. So I'm going to take each one of those blue points and shift 2 left. So I'm going to take this one and shift 2 left. Sorry, 2 left and 3 up. So I'm off the chart here, but 2 left and 3 up. It's like way up here somewhere. Okay, you get the gist. This is 2 left and 1, 2, 3 up. This is 2 left and 1, 2, 3 up. And this is 2 left and 1, 2, 3 up. Okay, that's pretty much what my graph's going to look like. Okay, something like that. All right, close enough. Here's your exit slip. You need to submit this to me in Schoology by the end of the class period. All right, so hold on a sec. I got to see what time it is. Oh, I have to sign on to your class pretty soon. So I'm going to start you off with this. We're going to do an XY chart. I think some good numbers to plug in. Hold on, let me just find some good numbers for you to plug in for your XY chart. So you're going to do 2 graphs. We're going to do, I think these are good numbers. We're going to do -1, 0, 2, 3. All right, so good luck. You guys do this exit slip. Make sure you submit it to me by the end of your class period. Thanks. Bye.